Today I will discuss about the poisson bracket. What is poisson bracket? Poisson bracket definition is just like the commutation relation. We know that. For example, we take poisson bracket of A and B and we denoted it by these symbols, and that will be del A, del xi, del B, del pi minus of del A, del pi and del B, del xi. Here xi and pi are the positions and their momentums. For example, xi's are x, y and z. Momentums are px, py and pz. We will elaborate. Here the summation sign will be there. Okay, let's say the poisson bracket between x and px. What will be x del x upon del px minus of del px upon में del x minus of del x upon में x del px upon में del px. And we know that x or px are, x is independent of px and px is independent of x. These are 0 and this is 1 and this is also 1. So x px poisson bracket is 1, and we know that commutation relation between x and px will be iota h cross. So here what is the relation between poisson bracket and commutation relation? Then poisson bracket of x px will be 1 upon me iota h cross x px. That is, poisson bracket of A and B will be 1 upon iota h cross AB. This is the relation between poisson bracket and commutation relation. Okay, let's take an example of poisson bracket. Let's find poisson bracket of R and P. What is R here? R is the position whose value is x square plus y square plus z square, and same P is px square, py square plus pz square. Okay, then we will find out the poisson bracket between R and P. So expand it using definition of poisson bracket. Del R upon del x del P upon del px. Summation, we use summation here. Then the next one is y del P upon del py. Then next one is z del pz minus of del R upon del px del P upon del x minus of del R del py del P del y minus of del R del pz and del P by del z. Okay, so here we know that R is this, and there is no dependent, there is no px and py pz terms, so this will be 0, this will be 0 and this will be 0. It means the negative terms are all 0. Okay, so remaining terms are this. Okay, now since we know that R is x square plus y square plus z square, we have to find del R upon del x, del R upon del y, del R upon del z. Del R upon del x will be 1 upon 2R into 2x. So by r. Similarly, del r upon del y, y by r, del r upon del z, z by r. Okay. Similarly, p is px square plus py square plus pz square whole root, and del p upon del px will be px by p. Similarly, del p upon del py, py by p, and del p upon del pz, pz by p. Okay, so we put in this equation, then position bracket of r and p will be del r upon del x. What is del r upon del x? X by r. Del p upon del px, it will be px by p minus of, plus of del r upon del y, y by r, py by p, z by r, pz by p. Okay, so this is x px by py z pz divided by rp. So these are, we know that this is the dot product of r and p, r dot p divided by rp. This is equal to r unit vector and p unit vector. Okay, there is one relation that is very important. Just like in commutation relation, we know that a, b, c, these are operators. What is that? A, b, c minus, plus a, c and b in this side. These are all operators. Similarly, in case of Poisson bracket, a, b, c will be a, b, c Poisson bracket plus a, c Poisson bracket and b in this side. Okay. Similar relation arises for the Poisson bracket also. This is very important relation. Similarly, a, b, c relation also. A, b, c is outside, p in this outside is c. This is very important relations. Okay. There are many times question comes up by the Poisson bracket. Just I did r and p Poisson bracket. Okay, the very important term in classical mechanics is canonical transformation. What are the canonical transformations? Canonical transformations are those transformations in which the equation of motion is invariant. Okay, means as the equation of motion are earlier with Hamiltonian h, then the equation of motion for k, the new Hamiltonian, will remain the same. Okay, so if we have given initially momentum and position, and by the canonical transformation the new coordinates capital P and capital Q such that the equation of motion are invariant, then this transformation is known as canonical transformation. Okay, if we have given P and Q in terms of P and Q, then we have to show that this transformation is canonical or not. Then how can we do it? Okay, as we know that Q and P Poisson bracket is 1. If by any transformation P and Q will arises, then if Q P Poisson bracket is 1, then this transformation is canonical. First method is first find the Poisson bracket of the new coordinates. If it is 1, then we can say this is the canonical transformation. And next one is, we know that Lagrangian is, if this is the Lagrangian, then we know that equation of motion for L and L prime will be same as I have told already. So what is L here? PQ minus H. And what is L prime? The new Lagrangian of new Hamiltonian K, P Q minus K plus dF by dt. Here F is known as generating function. Okay. Sorry, here Q dot and Q dot. We know that the Hamiltonian is PQ dot minus L. So these are the differential of time derivative. Okay. Now, if H and K are equal, means the generating function is explicitly does not depend on t, then the new Hamiltonian or old Hamiltonian will be equal. In that case, what is that equation? This equation becomes P dq upon dt minus H P dq upon dt minus K plus df upon dt. K and H will cancel down, and if we take derivative multiply by dt both sides, then we will get P dq minus P dq equals to df. It means if any transformation, we can show that f is perfect differential function, then the transformation between PQ to capital PQ will be canonical. Let's take an example. I will prove by both the methods, by Poisson bracket or perfect differential method, that transformation will be canonical or not. Let's take an example. Let's say we have given Q is root 2Q A cos of P. Here A is any constant given, and capital P is root 2Q E minus A sin of P. We have to find this transformation is canonical or no. First, find out using Poisson bracket. So we have to find Poisson bracket of Q and P. What was that? Del Q upon del small q minus of del Q upon del P and del P upon. So we have to find these parameters. Del Q upon del Q, what will be? Root 2 same, 1 upon 2 root Q, and the remaining term will be same, EA cos of P, then this will be 2Q EA cos of P. Similarly, del P upon small p, root 2Q will be same, and sin p becomes cos p. Okay, next one, del q upon small del p will be root 2q ea minus of sin p. Similarly, del p upon del q 1 upon root 2q e minus a sin p. Then q and p will be put the values of these parameters into this equation, and del q upon del q, what is this? This is the 1 upon root 2q ea cos p. Del p upon del p, root 2q e minus a cos of p, minus of del q upon del p, this will become plus root 2q ea sin of p, and del p upon del q, this 1 upon root 2q e minus a cos of p. Sorry, here this is sin p. Okay, root q cancel out, this will cancel out, this will cancel out, root q cancel out, and remaining terms are cos square p plus sin square p which is equal to 1. It means Poisson bracket of q and p, each one means the given transformation is canonical. Okay, the next method we will do it in this question by perfect differential. So let's take the same example. Perfect differential equation is p dq minus p dq equals to df, where f is generating function. We need to find it. Okay, first find dq here. What is dq? Q is given here. Then first take the derivative of q and then take the derivative of p. First take the derivative of q, root 2 remains same, and derivative root q is 1 upon 2 root q, remaining terms are same, plus term of q will be same, and differentiate of p, which will be minus sin p. Then this dq is 1 upon 2 root q e a cos of p minus root 2q e a sin of p. Then the above term will be p dq. Here dq and here dp term also there. Okay, then p dq minus p dq, put the value of p here. What is p? P is this, minus root 2q e minus a sin of p, multiply it by, take ea common in both parts, and remaining terms are root q cos p dq minus root 2q sin p dp. Okay, Let's take the left hand side of this equation. This is the left hand side. Then take dq common, and this term e cancel down, and p minus root 2q will be cancelled down, sin p cos p. Dq, and the remaining term is minus plus root 2q multiplied, and it will be 2q sin p sin square p dp. Okay, if it is perfect differential of f, and f depend on q, p and t. If f does not depend explicitly on t, then this is 0. Then the df from this expression will be del f upon del q dq plus del f upon del p dp. So compare this equation and this equation here. Del f upon del q will be this p minus sin p cos p, and del f upon del p here is this 2q sin square p. Okay, now here let's find f. What is f here? Integrate with respect to q, pq minus sin p cos p q plus some constant. Similarly here in this case, let's find f. Integrate with respect to p, 2q sin square p dp. Take the value of sin square p in terms of cos 2p. What is cos 2p? 1 minus 2 sin square p. Put the value here of sin square p, 1 minus cos 2p divided by 2 dp. 2 will cancel it. Q p minus sin 2p divided by 2 plus some constant c2. Okay, so this will be q minus q sin 2p divided by 2 plus c2, and let's expand the expression sin 2p. Sin 2p is 2 sin p cos of p. The 2 will be cancelled down by divided by 2, and this will be q sin p cos p plus c2. Since f from this expression f is this, and from this expression f is this, so both must be equal. So here c2 c1 c2 will be 0, and f will be pq minus q sin p cos p. So here what is the result comes here? We just find out the generating function, which is a perfect differential.